this is Junichi Horikawa, and this is the 7th episode for VEX for Algorithmic Design. And the topic for today is loops. To start off, let me explain what loop is. And this is the basic flow diagram for explaining the loop in any kind of programming languages. Whenever you want to do a continuous process, you use loops, and this is how it works. First of all, you set a conditions in what state you can run the continuous process, and whenever as long as you have a state which meets with these conditions, you can keep this process continuously. But as soon as the state leaves these conditions, then the looping process will be ended, then go to the next process. The basic idea of the loops is always the same like this, and it is the same in any kind of programming languages, including VEX. So whenever you have questions about loops, go back to this basic workflow, the flow diagram, and think that the basic idea is always the same and pretty easy. And any loop process that you thought it was too complex to understand will become pretty easy if you break down into this kind of basic workflow. In this tutorial, I'm going to show you the basic workflow in order to use the loops with a VEX, using several types of looping syntax together with some simple exercises. Okay, first of all, I'm going to show you the very basic for loop syntax. Okay, I'm going to create a geometry node, and inside I'm going to first create a sphere. Then I'm going to create a attribute wrangle. This time I'm gonna set the run over to detail, since I just want to run once. Okay, I'm gonna name this to for loop. Now let's try to create a bunch of points on x-axis using just a detail wrangle. And let's use that points to copy this point, copy this sphere to, so that we can have an array of sphere on a display. Alright, so first of all, let's set some numbers we can use to define the number of points we want to create. And I'm gonna write it like this using chi, so that we can have a parameter called num with the integer value. And as I told you in the parameter expression tutorial, we could click this button to show up the parameter in the sliders. So let's use this slider to control the number of points we want to use. Now I would like to use loop in order to create a number of points, and I'm going to start by explaining the simplest for loop syntax. And it is the most often used loop type. That is because you can specify the number of times you want to continuously run the process using this syntax. So I'm gonna explain how you can write it. So first of all, type for, then use parentheses, and inside the parentheses you type a condition how many times you want to run the process inside for the loop. And you also type curly bracket after it and close it like this. And inside a curly bracket you type a process you want to continuously run. Okay, so first let's start by writing some conditions how many times you want to run the process. Okay, so you start off by creating a variable. The simplest way is to create an integer variable like I and start by a value 0. And you type semicolon, and after the semicolon you specified the conditions when to end the loop. And if you want to use the loop, use this for loop in order to specify the number of times you want to run the process, then in most of the cases you write like this: I is smaller than num. So this means is that the loop, the process written inside this for loop will run as long as the value I which you have declared right here is less than the number which you have specified right here, which is currently is equal to 4. But as you can see, currently the integer I is equal to 0, and with just these conditions, I will become 0 forever, so it doesn't seem like it's going to end the loop. So another things you have to write is the how this I value that you have declared right here will change in each process. And that's the ones you want to write after this conditions. So you type semicolon again, and after this you type how this I will be changed in each process. And in most of the cases you type like this I++, which means that after each process I value will be incremented by 1. So it will start, the I will start by value 0, but after the process has been done, after the process written inside this curly bracket has all been done, then I will be added by 1. So in the next process, the value I will become 1. And that will continue until this I will leave these conditions. So when the I becomes 4, then that is equal to num, which means that doesn't meet with condition. So that's the timing when to leave this loop and go to the next process after the loop. So this is how it works with this for loop. And you can modify these variable, like starting by 0 could be any values. You can also change these conditions, or you can also change this incremental conditions for I as well. But most of the cases, the most used way to write the for loop is this way. So think that this is the kind of a template for loop. So most of the cases you type the loop like this. So if you're new to VEX or for loop, then start off by this simple template. Always try to use this template first. Then if you get used to it, then you can modify these conditions to do more complex for loops. Okay, so by writing like this, I have just made a loop so that any process being written inside this curly bracket will be repeated by the number of times you specified right here, which is currently equal to 4. So any process that I write here will be repeated 4 times. So let's try to create a point 4 times so that 4 points will be added as a geometry. So in order to add the point, first you specify the point ID as a variable. Declare a point ID that variable, then use a function called add point. Okay, and the first parameter will always be 0, so just type 0. And the second parameter, we have to specify the point positions. So for now, I'm going to set as 0, 0, 0. The point position has to be set as vector, so I'm just using set functions in order to create a vector which x, y, and z coordinate is equal to 0. Okay. So after doing it, and click anywhere in the canvas and look at the for loop at the node that I have created, and click middle button, then you'll be able to see that there has been a 4 points inside this node. So I have just successfully created 4 points using this code. And if I change this slider to some different numbers like 7 and middle click again, now I see that 7 points are being made. So the loop is successfully working as I expected. It's a bit hard to see with this background color, so I'm gonna set the background to dark. You can show this display by placing your mouse in a viewport and press D key and go to the background and set dark. And currently the point position is at 0, 0, 0. So even though there are 7 points right now, all the points are being set at the same positions. But actually what I really want is to have those points line up on X direction, maybe by a distance of 1 for each step. But currently I have set the point positions as 0, 0, 0, so all the points is at the same positions. So in order to change it, there is just a way to do it, and that is by using this I value. As I told you, as I explained before, the I value will change on each process, in this case added by 1. So it start off by I equal to 0. So in the first process, I is equal to 0. And in next process, after finishing this process and after doing the second process, after doing when it comes to do the second process, the I will become 1 by using these conditions right here. And it will continues until the I will become equal to 7. And when the I becomes equal to 7, then based on these conditions on the middle right here, we'll end this process. So the I will continuously increase from 0 to 6 in this case. And in total, you have 7 numbers. So you can actually use this I value, I variable inside this process to use it for many purposes. And one of the purposes is just to use it as it is for example, using for X coordinate. So I have just replaced the X coordinate with I, and as a result, you'll be able to have this point position being changed at each process in the loop. So first process will be create at the point at the 0, 0, 0 positions, but the second process, the point will be made on 1, 0, 0, and third 2, 0, 0, and so on. So this is pretty essential when it comes to use this kind of for loop syntax. You can use the variable that you have set inside the conditions inside the process, and you're going to use it a lot. You're going to use this I or any variable that you declared in the conditions a lot in order to make the process inside the loop be different in each process. For example, you can use I as a random seed for the random value so that you always get a different value in each process and so on. Okay, now that we have created the point array using a loop, let's use copy to subnode, copy to point subnode to copy those spheres on a point. And let's set the sphere size to say 0.5. And here we go. Now, after doing it, I can change this slider's value to change the number of spheres laying out on X direction. Now that was the very basic using loops in order to create a point from scratch. Now next, let's try to use this same for loop syntax in order to access to the points that has already been created, which is those 7 points that I've created using this for loop. So to do that, I'm going to create another attribute wrangle, set the name to say for loop 2, then also set the run over to detail, and connect the for loop 1 to for loop 2 like this. And let's try to access to those points using for loop. Now the syntax is the same, so let's start by writing for and close with parenthesis and also close with curly bracket. Now inside a parenthesis you type int I equal to 0. So I have created a variable called I, start with 0 value. Then the conditions that I want to create is to say I want to access all the points. So in order to get the value, the number of points which exist from this first input that I've just connected, you can use a function called nPoints, which you can count the number of points in specified input numbers. And since I have inputted on the first input, you can type 0. If you inputted it on second input, then you can type 1. Right? So that will be the conditions for how many times you want to run the loop. And since I want to increment by 1 for each loop, I just say 1 plus plus. Right? So now I think I have made a loop which continuously run for 7 times if I have 7 points exist from this full loop. Okay, so what I want to do next is to access to each point and maybe change some attributes for each point. And let's try to create a random color values and set it as an attribute to each point. Now, first of all, let's try to create a random colors. So I'm gonna name it as vector col. The color value is vector because you need to have our red, blue, and green values. So that will be 3 vectors. And you can use a rand function in order to create a random vectors. And in order to use a rand functions, you need to set some random seed inside parentheses for these functions. And if you set the values inside rand be the same constant values like 0, then even if you do the loop 7 times, you always get the same color value. Well, let's try to see that first. And if I have created the color value, next thing you want to do is to set this color value as an attribute to each point. And in order to access to each point, you need to know the number, the ID for each point. But since these are the only points you are accessing it right now, so you can really check it by clicking this point number button right here on the middle. And let's also make those numbers a bit bigger. Right, so it starts from 0 and end at 6. So these numbers will be equivalent to the number you get from this I value, because you are creating a 7 times process, and I starts from 0, which is equivalent to this, and end when the I becomes 6. So what you get as a value from I is equivalent to those point numbers. So you can just directly use this I as a point number, right? So you can use a function like set point attrib in order to set the point attribute at specific point number. So the input is equal to 0 because you have set it to first input, and the number, the name of the attribute that you want to change now is CD, which is a preserved attribute in order to specify the color of the points. And the number that you want to access to is equivalent to I, so you just type I for the third parameter, and last you set a actual values that you want to set as a color. So I'm gonna set col. Okay, now currently it's a bit hard to see what color is that I have created, so let's try to use the copy to points again to show the sphere. So I'm gonna create the copy to sphere, and I'm just going to copy the same sphere to those points that I've set the random color. So as you can see, all the points has a color value, but even though I have used the random values right here, random functions right here, all the points have the same color value. That is because I have set the random C as a constant value right here as 0. So in order to change the value, in order to change the random value at each iterations, you need to change the seed inside the parentheses as well. And in this case, we can use this I value as a random seed. So let's try to see that. If I replace this 0 with I, then you can change the value. You can change, and each iterations, the parameter inside random will be changed. So as a result, you'll be able to get a random color value at each iterations. Now, if you want to control the random seed as well, then you can probably multiply some additional parameters, maybe named as seed, and use the sliders to change the random seed, so that you can change the values that you can get at each iterations. So you just have modified this I with some multiplier right here. So this is one of the popular way to use for loop in order to access points and use I value as some different purposes. Now that we have used the for as loop syntax, let's try to use the same syntax to create a bit more complex shapes like helix shapes as an exercise. Okay, let's create another attribute wrangle. Let's name this exercise 1. Set it to detail for run over. And let's try to create a points array which is aligned in as a helix shape. Now let's start by creating a parameter, how many points that I want. So as I did before, I'm gonna use chi to specify the number of points. Right, maybe number 10, maximum 10 might be not enough, so I'm going to raise up the range by going to the edit parameter interface, check the num parameter interface parameter that I have created, and set the range, the maximum value, to be 100. Apply, accept. Okay, now that I have a maximum range until 100. Now let's create a for loop. Like I did before, I'm going to create a conditions to run the for loop process using this num value. So in this case, I'm going to run 60 times, right? And I also am going to create a position value in order to use it for the point position for point that I'm going to create. Let's start off by setting at 0, 0, 0 and use at point function to create a point at this position that I've created as a vector variable. Okay, now there is 60 points being created at center points. So first of all, I want to create it as I want to lay out this point in a circular layout to make it as a helix shape, to be the base for the helix shape. In order to create a circular shapes, what you can do is to use a trigonometry. Now say this is the center point, and what you want to get is the point position at each point which is on a specific circular shape. And in order to get these point position, what you need is just an angle from the center point, which is equal to theta right here. So if you want to get this one, then what you need is this angle right here. And in order to use this theta, you can extract the coordinate for x and z with this. X equal to cosine theta, and z can be equal to sine theta, like this. By using this simple format, this simple trigonometry, you'll be able to get the coordinate for this point x, z. The reason why I used Z instead of Y is because in Houdini, Z is the ground plane coordinate and Y is the height coordinate, so that's kind of a reason why, but it could also be Y as well. So, and same for this one, if you want to get this value, then X is equal to cosine theta dash Y Z is equal to sine theta, like this. So, based on this information, let's try to create a circular point coordinate together with the I value inside the loop. Okay. And as I said, the I will change from 0 to some specified numbers, and could be like 7, could be like 8 or so. So, and it is incremented by 1. Okay, so you have 0, 1, 2, 3, and 4, and so on. And in order to use I for an angle, what you can do is to first specify like a step angle. Like this theta could be a step angle. Like say this is equal to 30 degrees. Then you can use this theta as a step angle to multiply with this I to create a next point angle, and next point angle. So when the I is equal to 0, then I multiply theta is equal to 0. But when I becomes 1, then it will become 30. When I is equal to 2, and it will become 60, and so on. So the first angle should be right here when the theta is equal to 0. And the second second angle will be 30 degrees, which is equivalent to this angle, which will give you this point value right here. When it is 60, then you'll be able to get this point value, which is equivalent to 60 degrees. And with 90, well, this is actually not a 90 degrees. It should be right here. That is because I didn't separate the pi in correct ratio. But when it's when the I is equal to 3, then the point should be right here, and so on. So, in order to use I, let's use the I in order to control the angle one by one by multiplying it with some step angle value. Okay, so let's do that. First of all, let's split X and Z value differently so that it'll be easy to see. Okay, so for X value, we're going to use cosine function. And for Z value, we're going to use sine value. Okay, now for the cosine and sine, we're going to use the same angle in order to create a point which is on the circular circle. Okay, so let's calculate the angle using this I value right here. So first of all, I'm going to type I, start by I, and multiply with some step angle right here. And the angle can be used, the angle that I have to specify right here inside the cosine function or sine function has to be in radians, which means that when we use pi, this means 3.14, which is equivalent to 180 degrees. So this is the radians value. If you type $pi, this is the preserved global variable which you can use inside VEX, and you can always type pi in order to declare 180 degrees in radians. So let's use pi, and pi itself will be a bit too big for step angle, so let's make it a bit smaller by multiplying it with some small values like 0.1. So as a result, 180 degrees multiplied by 0.1 will become 18 degrees. So in this case, a 18 degrees will be a step angle, and multiplied by I will increase the angle in each loop process. So let's create the same angle value for sine. I'm just going to copy paste inside a sine. And now that I have created x and z value right here, let's replace this position for x and z with those variables that I've created. And let's see the result. And as a result, I have successfully created the point position on a circle with the radius of 1. If you want to change the radius, you can multiply this cosine and sine with specified radius. If you want to set the radius to 2, then you can multiply those sine and cosine by 2 to create a specified radius. But for now, I'm going to keep it with 1. Like this. Now next, I wanted to make it as a helix instead of just a circle. So in order to do that, I also need to change the height value, the y value. And for height value, I could still use the I value as well. For height value, I just need to make additional value for each point step by step. So I just need an incremented value for the y value. So in that case, maybe I can just use I as it is. And let's see that. Now it starts to create some really long helix curve, helix shapes, but it seems like the distance between the first point and the second point is a bit too big, so let's make it a bit smaller by multiplying it with some small value like 0.1 or so. And now I start to see some helix-like shape in a point array, and it looks like this. Okay. Now maybe I am right now using a constant value for the angle step and the height step right here, but maybe I can parameterize these values as well. So let's try to do that. Maybe I can create two parameters, one for the angle and one for the height currently at, which can be replaced with the 0.1 that I have set as a constant value. So let's create angle, let's name this angle ratio with a float parameter. I'm gonna name this angle ratio, and for the height I'm gonna name this height ratio, CHF height ratio, like this. And let's promote this. You'll be able to have a value in between 0 to 1. So let's replace this angle ratio with the value that I have multiplied right here inside the cosine and sine. And for the height ratio, let's replace this value with this one, 0.1, that I have multiplied with I for the y coordinate. Now I can try controlling those sliders in order to see the changes when I change those sliders in order to change the shape. Alright, this looks good. Now let's try to copy the sphere to that point to see it more clearly. Copy 2 points. Set the sphere size 0.2, and now you'll be able to see a helix a bit more clearly. Right? Or maybe you can use a add node to create a curve which connects all the points. So add node, go to polygons, go to by group, and you'll be able to see a polyline which connects all the points in an order. Okay, so a bit more practical way to use for loop in this case. And could be a will be a good exercise for you to actually know how this will be used in a real geometrical processes. Now let's try to use other loop syntax, which is called while loop and do while loop. Okay, so let's start by creating attribute wrangle again. Attribute wrangle named as while loop, and I'm gonna set the run over to detail, and let's try to use while loop to see what it can do. And when it comes to while loop, the difference between the for loop that we were using is that the condition that we're going to set is going to be a bit more simple, but at the same time there's going to be a bit of dangers using it, because when you use it, there's a lot of chance that you're being fell into an infinite loop, which will crash the application, in this case a Houdini. But there are many cases that you want to use while loop as well, so let me explain how you can use it. So let me start off by creating a very simple conditions, same as the for loop conditions that we were using, to create a number of points using a specified numbers. Okay, so first of all, I'm going to create a number of points that we want to create, using a parameter, integer parameter. So I want to create a conditions to create a number of points. Like if I set the number to 5, then I want to create 5 points with a while loop. So let's see how we could do that. In order to create a while loop, first we type while first, and then we use parentheses, then curly bracket. So it's pretty much similar to for loop, but what you can write inside the parentheses is just one conditions. It's just one condition without any semicolons, which make this loops pretty simple, but at the same time really dangerous. Now, since I cannot declare any variables inside this parenthesis, and in order to use with these conditions that I have set as a number of points that I want to create, first, in order to create a conditions that I want, I'm going to create a variable outside the loop just before going inside the loop, maybe named as I, and start with 0, like this. Now, inside for the conditions, I'm going to set a conditions like I is smaller than num, like this. So this loop will continuously run the process inside the curly bracket whenever the I is less than number. So whenever I is in between 0 to 4, then the process will continuously run. And if I write some code to, like, say, add a point with 0, 0, 0 and try to finish this at this point, then you're gonna get into some problem, because as I write it like this in a simple manner, and you realize that I will not be incremented in each process, so that means that I will be kept as 0 forever. So this means that you cannot leave this loop with this conditions written right here. So if you click on the canvas, then you'll fall into an infinite loop, which will be fell into some problem. So let me just comment this out first. And first, let me save the file somewhere, maybe on the desktop, and try to run this by uncommenting this out to see that we are going to fall into the infinite loop. If I click the canvas, okay, I need to, in order to use add point, I needed to say 0 set And if I click it right here, now if you look at the left bottom corner, it says it's processing the VEX code, but it never ends. That is because we are falling into the infinite loops right here, and nothing will happen if I click in anywhere, even if I type escape. Doesn't end, and we are getting into the problem. And now what I can do at this point is just to force quit the application, which is not responding. So that's the problem. Okay, I've just reopened the file. Now whenever you want to use loop, be careful that there is a big chance that even if your experience fell into a infinite loop like I've just showed. So in this case, in order to leave the loop with these conditions, you need to somehow increase the I value so that at some point the I will become bigger than this num. So what you can do is, the problem is that you cannot type the conditions so that I will increase by 1 like we did for the for each loop inside its parentheses, but you have to type it inside the process, inside a curly bracket, in order to change the condition, in order to change the I value. So what you can do is to say I plus plus inside the curly bracket as a process to increment I by 1 at the end of the process. So by doing it, and each process, the integer I will be updated so that it will increment by 1 at each process, and at some point I will be bigger than the num, and as a result, okay, I also have to change this one. That's it. At some point you'll be able to end the loop, and as a result you have just successfully created 5 points, which I have set it as 5 for the number right here. So if I set the number to 7, you are creating 7 numbers. So basically what it does right here is pretty much the same as for loop, but the syntax, how you write the loop, is a bit different, and it's a bit dangerous way to write because there's a big chance that you're going into an infinite loop. But using while with this simple conditions, sometimes it's pretty useful when it comes to deal with a loops when you don't know how many times you want to continuously do the process, but you don't know the process, you don't know the number of process, but you want to do the loop based on some environmental conditions. And one of the good example is the recursive like calculations, but that will be a bit more advanced topic, so I'm gonna talk about it in other videos, or maybe later videos. Now with this while loop, I is also incremented by 1 like we did in for loop. We can use I for the x value for the point to continuously create a point array aligned on x coordinate like this, and probably use the same sphere with the point to sop, copy to point sop to place the sphere on those array points like this. So as a result, what you get is pretty much the same as for loop, but the way you write and the things that you need to be careful is a bit different. Now there are similar loop syntax called do while loop, which is similar to while loop. Let's also try to do that as well. Since this data is pretty similar, I'm just going to copy the whole network which I use for the while loop, and I'm going to rename this to do while loop. Now the syntax goes like this. First you type do instead of while. So I'm going to cut this conditions right here and say do. Okay, and in order to finish the do, I need to set the conditions right after the closing curly bracket. So using while loop, while conditions right here, and end with a semicolon like this. And as a result, it'll just give you a pretty similar result. It just created, it doesn't give you any error. It has created 7 points with this number that I have created using this conditions. The only difference between a while loop and a do while loop is that if I set the number to 0 right here, when we were using while loop with a value 0, since the number which I've set it as 0 right here is already doesn't meet with this conditions, which means the loop, the process inside the loop won't run even once. So as a result, you get 0 points right here. But for the do while loop, even though we have set the number to 0, we still get single points created right here. This means is that even though the condition didn't meet with the conditions that I have written right here, with the while conditions right here, it still runs at least once the process which is written inside this do loop. And the result that I get is pretty much the same even if I set the number to 1. So the difference between the while loop and do while loop is that when you use do while loop, it just runs the process before checking the conditions, then check the conditions after you run the first process. So that's the reason why you get even at least a single process run, even if you set the conditions to even if this condition doesn't meet with the current state. So even if you set the number to 0, you still can run the process at least once. So in some of the cases, you might want to use this instead of while as well. But most of the cases, I guess using while loop is much popular than using do while loop. And same as while loop, you need to be careful about how to set your conditions, because there is also a big chance that this will fall into a infinite loop as well. So keep that in mind. And if we show the circle, what we get is the same result as a while loop. Right. Now let's go to the next topic. Maybe you're really not sure yet when to use this while loop instead of for loop, so let me give you another exercise to use this while loop to create a bit more complex geometry. And let's try to create the same helix shapes like we did for the for loop exercise using this while loop instead. And I'm going to change the conditions when to end the loop. Last time when we were using for loop, we were setting the conditions at a number of points. But using the while loop, I'm going to set the conditions so that when the total rotated angle met with a specified value. So that will be the conditions that I want to use for this while loop. Okay, so let's create an attribute wrangle again. Attribute wrangle named as exercise 2. Set run over as detail. So first of all, let's set some parameter in order to use it as a conditions. And in this case, I want to create a parameter to define the total angle, how much the helix geometry should be rotated. So I'm gonna name the variable as total ang, and then create the angle parameter by multiplying the pi, which is equivalent to 180 degrees, multiplied by some float parameters, like named as total ang. Okay, and let's promote this. Now in default, the value is in between 0 to 1, which might be too small, because that means if I multiply it by pi, then the value is between 0 to 180 degrees. So let's increase that a little bit, going into edit parameter interface, click total ang, and let's set it to 0 to 10. Oops, 20 might be too big. Let's set it to 0 to 10. So the range now becomes between 0 to 1800 degrees. Alright. Now let's also have a angle ratio and height ratio that we had when we were using for loop as well. So ang ratio is, which could be in between 0 to 1, ang ratio, and height ratio in order to control the height step. Right, so let's also promote these two values, which is in default from 0 to 1. That is fine. Now let's also create a variable which is going to be used in order to create a conditions for the while loop. So I'm gonna name it as current ang, start with 0, and I want to use it as a radians value. Right, now let's try to use the while loop. While some conditions, curly bracket. Okay, let's open up some space right here, and for the conditions that I want to write here is something like this. Whenever the current angle is smaller than total angle, then keep doing the process inside the while loop. So which means in order to end this loop, you need to increase this current angle step by step in each process, so that at some point this will be bigger than the total ang. So before writing any process, let's write that. Let's try to write that so that you are promised to end the loop at some point, because without it, and if you activate it without this line, then there is a big chance that you fell into an infinite loop again. So the current ang, add the current ang by some value using plus equal. Plus equal means add some value to the current angle, or some other variables. Okay, and what I want to add is the angle, the step angle. So we can use this ang ratio multiplied by maybe a pi. So pi multiplied by ang ratio. Okay, so as a result, if you activate it, okay, I think I have missing a. Okay, so if I activate it, it doesn't give you an error, which means you have successfully left the while loop using these conditions with this current ang implementation. Okay, so if the angle ratio is equal to 0.1, then at each step, at each process in the loop, the angle will increase by 18 degrees. And so the current angle will be increased by 18 degrees. And if the total ang is equal to, say, 180 degrees, then I guess you're going to do 10 times loops until the current angle will become bigger than or equal to a 180 degrees. So using this while loop, using this kind of conditions, you are not declaring the exact number of times you want to do the process, but you're just setting a conditions when to end the loop, which in some cases it's pretty convenient because sometimes you don't know how many processes you need to do in order to get the result that you want. Okay, and in this case the result you want is to have the total angle to be at specific value, which is in this case pi multiplied by the total angle that you've specified right here. Alright, so after this you can just do pretty much the same things like we did in for loop. First we need to create a positions for the point using cosine and sine. So let's create a x and z value first using cosine and sine, and inside the cosine and sine you need to specify the angle. So the angle right here, the angle that you can use is actually this current angle itself, so you can just copy paste like this. And for the height, you can create a height by using a height ratio. And in this case, we don't have a value I, so we might need to create another variable outside a while loop, maybe named as current height. Start from 0. Then at each iterations, you might want to increase the current height by this height ratio. And use y value as this current height. So as a result, what you get as a vector for the point position is x, y, and z. And finally, let's add a point based on this position using add point function like this. And you'll be able to create a helix geometry just like we have made using for loop, but only the difference is that the condition is different. Current conditions we are using is a total angle for this helix. So if I set it to 2, whenever even though you change those angle ratio or height ratio in any values, the total angle of the helix is always the same, like this. And based on the angle ratio, the number of points created will be different, but you still keep the angle the same with this total angle. So this is kind of one of the example you want to use while loop when you don't know how many points you want to create, but you have other kind of conditions like keep the total angle to be specific values. If you set it to 4, you have to rotate it a circle like this. But if you change the angle ratio to bigger one, you have less points. If you make it smaller, you have more points. You can control, or you can also control the height. Alright, so this is one of the example why you want to use while loop. Okay, let's finish this by adding a add node to a point and connect those points to create a polyline. Alright. Now let's try to use other loop syntax, which is called as for each loop syntax, which can be used together with arrays. So to start off, we need to have some array values. So let's try to create the array using a for loop that we already have used. For loop syntax that we already have tried out as a practice. So I have just created attribute wrangle. Let's say create array, and then set it to detail. Then I'm gonna set the number of values that I want to create. Let's with the parameter called num. Okay, and let's use a for loop to continuously create the process with the specified number that I have just set with the num. And before going to the for loop, we're going to create an empty array first. So I'm gonna name this as values using array. So I have just created an empty array named as values, and inside this for loop I want to create some values inside here, and then put that values inside this this array, and as a result you'll be able to get a array which contains the value that has been created inside this for loop. So to do that, what we can do, maybe we can just pass in this I value, which is going from 0 to 3 in this case, 0, 1, 2, 3. So to push the values, push any value inside the array, you can use push functions, and then first parameter will be the name of the array, and the second parameter is the actual value that you want to store in, in this case I. Okay, and let's set as a detail attribute named as values, like this, and let's check this out going to the geometry spreadsheet. So click this plus button, go to inspectors and geometry spreadsheet, go to the detail, and you have successfully created an array which contains from 0 to 3. In total you have 4 numbers. And if you change this sliders like to 7, as a result you'll be able to create an array which contains in total 7 numbers from 0 to 6. Okay, now you have successfully created an array. Now it's the time to use a new loop syntax called for each loop in order to access to those value inside an array. Now to do that, let's try to create another attribute wrangle. Okay, and connect the node which has an array as an attribute, and let's name this for each loop. Now first of all, let's retrieve the array value from the detail attribute. Before doing that, let's change the run over to detail as well, and let's get the attribute as named as values from a detail attribute like this. Okay, now in order to access on each values which is contained inside array, what you can do is something like this using a syntax called for each with a parenthesis and a curly bracket. So inside the parenthesis, you need to type in what array you want to access, and for each value inside a array, how you want to name it. So first you set a variable name for the value inside this array, and since you are accessing to a integer array, you have to create a variable as an integer. So say integer value, and next you type semicolon, and as a second parameter you have to type in the actual array that you want to access to. So in this case, the values is the name of the array. So this is the very basic look for this for each loop, and inside the process, inside a curly bracket, you can use this val, which is each value inside this values array. So let's try to use it as a x coordinate for the point like we did before. And pt code to add point and use set to set the point positions, and you want to set the x coordinate as this value, so say val 0 0, and what you get is using the value inside the array as an x coordinate and create a point like this. So inside, if you check the detail attribute again, it says that it's going from 0 to 6. So you are just passing the value from the array to a for each loop and accessing to each value one by one using this for loop. Now, if you want to access to a value inside the array, this for each loop is pretty easy to use, since there are less parameters you have to set, and it's pretty easy to access to each value inside the array. But in my opinion, I don't use this that much, even though if you want to access to an array, because you can also access to a value using a for loop that I explained previously, and most of the cases using a for loop is much more flexible than using for each loop. For each loop would work if you just want to access to each value and don't need to use any other information like in what iteration you're in when you are using the loop or so on. So you can use for each loop whenever you want. You only need to access to each array's values, and you don't need any other information than that. And then in that case, using for each loop works very well. But in other cases, using for loop is much better in order to access the array. So I'm gonna show you how to do that as well. In order to access to a array value using for loop, let's try to use another attribute wrangle. Set it to detail. Let's use for loop to access array. Okay. Now, same as we did for the for each loop, first we need to access to a array value. So let's create a variable for the array named as values and access to a detail attribute by saying I square bracket at values, because values is the name of the attribute on a detail. And in order to use a simple for loop syntax, we can use this template, and for this conditions on the middle, we can say, since we want to access to each numbers inside the array, what we can write here is the size of this array, and the size of the array can be retrieved by using a function called length and together with the array. So the length parenthesis values will give you the total size of the array, which determines how many values are inside this array. So this will be just the conditions that you want to create in order to access each values. And in order to access to each values inside an array, we can use this I as an index in order to access to each value. And to do that, we can say, if this is an integer array, we can say int val is equal to values square bracket I, and then you can access to a value inside an array at specific index in specific positions. Now this by doing it, you have just done the similar thing that is written like this. For when you use for each loop, you have just set a conditions together with the variable that you want to retrieve from the array named as val. We also set writing like this will just do the same, pretty much the same things, just name the variable as val, which is part of a array value. Now the difference is that for loop will be able to give you an additional information, which is this I value. And a lot of cases having I value is a very good thing because you can use it for many purposes, and you also know that the I will increment it by 1 all the time. But when you use for each loop, you don't have that kind of additional information, so you don't know. You have to declare additional information if you want to know in which iterations you're in right now using for each loop. So it looks like this is a bit easier to use, but if you want to do complex operations, maybe it might be better to use this a lot of times in order to make it as your go-to loop syntax. And if you get used to it, maybe in some cases you can switch the function to for each loop as well. To create a point from this value, you can just do the same things. Int pt equals at point 0 set val 0 0, and you'll get the same result, right? And to create a point, to create spheres on a point, maybe you can just copy from one of the examples that we did previously and connect it like this. Now both for loop will give you just the same result, just that the way you write is a bit different. And personally I would recommend writing like this using for loop instead of for each loop, but it's just your based on your needs. Now let me show you one situations as an exercise to access to a value inside an array using for loop, which is this case, and to show you the benefit of having I value. Okay, so first I'm going to create a attribute Wrangler again, set it as detail, name as exercise 3, and I'm going to create another helix geometry, but in this case I'm going to control the normal direction of each point, so that when you copy the geometry on each point for the helix point, all the geometry will be aligned based on that normal direction. And to see the effects, I'm going to copy the box geometry. So let's try to see, let's go back to maybe exercise 1 to see the current conditions. So in this case, we have a point like this, and when I try to copy the box geometry to each point, maybe set the box size to say 0.2, you see that the box has been copied to each point, but the orientation of the box is always the same. So all the faces are facing X, Y, and Z directions like this. But what I want to try now is to align this box orientation based on the flow of this helix, and make that flow by using the first point and the next point. So using that as a vector to control the normal direction of the point so that the box will be aligned like it is following the helix shape. So that's what I want to try to do by using accessing to an array together with the for loop with this exercise 3. Okay, let's try it. Let's try that. Open up the code editor, and first of all, I'm gonna set the number of points that I want to create using chi num. Okay, let's also increase the number of points that I want to create from 0 to say 100 as a range. Right. Now let's also create a angle ratio variable and height ratio variable like we had. Before, in order to control the angle step and step angle and step height, which is in between 0 to 1. Right. Now, first I'm going to create a empty array called positions to store all the positions that I'm going to create, which is going to be a position for the helix geometry. Okay. So instead of adding a point at this point in the first loop, I'm going to create a position and store that in this array. Okay, so let's try to do that by creating a same for loop that I did in exercise 1 and creating a position vector creating x, y, and z coordinate. The x is equal to using cosine with the angle, which is multiply pi multiplied by angle ratio, and also multiply by I. Float z is using sine to use the same angle, so I'm going to copy the angle value right here, paste it inside the sine parenthesis, and for the y value, which is the height value, I'm going to multiply I by height ratio. Okay, and use x, y, z to create a helix point positions. Now I didn't add the point as a geometry yet, I have just created the vector value, and what I want to do now is to store this vector value inside this array for the vector. So push positions pos positions pos. Right. Now, after leaving the vector, I should be able to get an array which contains all the point positions in order to create a helix geometry. Let's check that out by setting it as a detail attribute just to check. So positions equal to positions and if I go to the detail attribute, you see that several array value has been stored inside a position attribute as an array. Okay, now the reason why I have set the point positions inside an array first without creating a point position, without creating a point geometry, is because I wanted to refer to the first point and the second point in order to create a vector in between 2 points, and without having an array, it's a bit hard to define the current point and the next point positions. So it will become easier if you have already created positions to refer to the first point and the second point, and the second point to the third point, and third point to the fourth point. So that's kind of a reason why I've created array first and store all the point position first. Now next thing you want to do is the access to each of the point positions and also access to the next point positions which you're accessing to right now. So I'm going to create another for loop, which is go from I equal to 0, I is less than length of the positions, and I plus plus. Now what I want to do now is to modify these conditions a bit, so that I'm going to subtract this length of the positions, which is the total number of values which is inside the array, subtracted by 1. The reason is because I want to retrieve the point position using I index, and I also want to retrieve the point position for the next index to the I value, which means I plus 1. So and I know that the I will, without the subtract 1 value, the I will goes until the total number of positions minus 1. So if you have 10 values inside array set, then the last number for the I will be 9, and which by using 9 you get the last point positions. But if you do that, then the next to that last point you don't get any points, so that means you cannot create a direction between the last point to the other to the next point, because there is no next point. So by restricting the end loop conditions to a negative subtracted value, which is total, which is 1 subtracted from a total size of the positions array, you'll be able to get the last point together with the point which is the last point you retrieve from this loop can have the next point as a reference to create a direction. So that's kind of reason why I set -1, 2 as a conditions to the total size of the positions. So which means you can first retrieve the point positions using I like this, but you can also retrieve the next position named as position 2, writing like I plus 1. And by using a subtracted 1 calculation right here, it is assured that even if you type 1 plus I plus 1, you'll be able to access all the points and doesn't go over the number of arrays, even if you write it like this. So you have the point on specific index and the point which is next to that specific index point position. And as a result, you'll be able to create a directional vector by subtracting 2 vectors, something like position 2 minus position 1. Now let's also name this as a direction, position 2 minus position 1. Now I'm going to explain the detail about vector at a different tutorial as well. Just remember, you can create a vector in between 2 points like this for now. Okay, now's the time to create a point using at point at position 1. So let's take position 1. We'll create a similar helix geometry, and what you can do now is to use this direction to store this direction as an attribute to each point that you have just created as a normal direction. So set point attrib 0 as a normal. Capital N is the preserved attribute for a point, can be used to set as a normal direction. and pt is the point number that you have just created, and the value you want to set is direction, like this. And as a result, you have created a point together with a directional value, a normal value, which is called n. And with this n, you can control the direction of the copied geometry using copy to points. Let's place the box, maybe set the size to 0.2, and let's check the orientation of the box based on the normal direction. Now it's a bit hard to see. Let's try to reduce the angle step, height, and you can see that each box is aligning to the helix curve geometry, helix point geometry. So it's referring to the next point. Each point is referring to the next point as a direction, and using that direction to control the orientation of the box, like this. And you'll be able to create this kind of a smoothly oriented box shape. Maybe you can also add some up vectors as well. To make it a bit more with a y direction, to make it a bit more smoother. Now about those stuffs I'm going to explain in the vector topics later in other videos, but for now you can remember that you can do something like this using normal and up. So this is kind of a situations you can use for loop in order to access arrays in a practical way. And as you can see, it's a bit hard to do this kind of stuff using for each loop, because for each loop can only access to the exact value inside the array, but you cannot access, you don't have additional information like I. So remembering to use for loop in most of the cases is a good idea, even if you're dealing with array, and even if there are easy way to access to arrays. So I have just explained all the loop syntax which is available together with the VEX, but there is one thing I want to show you as an addition, which is a nested loop. Nested loop means that you can actually create a loop inside another loop. And there are many cases you want to do like that, so yeah, let me explain how you can do that. Let's create another attribute wrangle. Attribute wrangle, set it as detail, and let's name this nested loop. And I'm going to use the most simple for loop for these examples, but can be used for while loop, do while loop, or for each loop as well. Okay, so in order to create a in order to use the nested loop, I'm going to create a grid shape, grid points on a grid using a nested loop. So I'm going to create two parameters, one for the x direction and one for the z directions, to define the number of points on those directions. Like this, num1 and num2. Promote it so that I have two sliders as an integer. Now, first I'm going to create a single loop using num1. So int I is equal to 0, I is less than num1, and then I plus to increment by 1. And let's create a point pt equal to at point 0 set, and I'm gonna use I itself as a x value, so I 0 0. So this is the for loop that we were using, right? Now there you can also use you can also declare another loop inside the loop right here that you have just created, which means you can type it like this: for loop integer n equal to 0 and num2 and plus plus, and create a loop like this. So this is how you call nested loop. You have loop inside another loop. By doing it, you can use another variable. I have changed the variable name to something different from I. You cannot use the same variable name, so you have to change the variable name. I mean, I was using I for most of the cases, but you can also change this to like T or maybe ang or something like that. It's up to you how the variable name is. For the second loop, I have named the variable as n, and similar to the first loop, starting from 0 and end at num2 n plus plus. And this means that I have additional variable that I can use, additional incremented variables that I can use inside the process. And if I want to create a values in z directions, I can use that n for the z position coordinate for the point. And as a result, I can create a grid related point. The reason why I can create this kind of grid point using this nested loop is because maybe you can look at this first loop. Start from looking at this first loop. Okay, so when you run the loop inside the loop, you first run this loop inside. The first loop that's run is this one right here, which is the child of the parent loop. Okay, so starts from the child loop. So this will create a value n, which goes from 0 to a number 2, and the number 2 is currently equal to 7, so it's going to create a value that goes from 0 to 6. Okay, so this n value will be incremented one by one, and when the n value is increasing from 0 to 6, the I value stays at 0 in the first loop. So, which is something similar to like this. The point is created on z direction one by one by first creating a point like this, using the for loop, which is this one. And after creating the one line of code, after one array of points, then it goes to the next step for the I value. So this is when the I was equal to 0. And when the I becomes, and when you have created one line of points in a z coordinate and x equal to 0, then you go to the next step for the I loop, for the parent loop, when the I is equal to 1, so which is similar to this one. So the I has incremented by 1, and a new line when x equal to 1 appears. And then you continuously do this z loop again from 0 to 6 again for the second loop, and continuously doing it, first finishing this loop and then do the second iterate or next iterations for the parent loop. And as a result, you'll be able to create a grid point like this. So the number of process that you're going to do is actually a multiplication of number 1 multiplied by number 2. So which means in this case 7 times 7, 49. So in total, you are running 49 times process for this, the one that it's written inside this curly bracket. So in total, you are getting 49 points as a result using these conditions. So that's the nested loop. If you want to create a 3D grid, then maybe I can copy it to the next. Then you can just add one more loop. Int n, int t equal to 0, t is less than num3, t++. Let's also add a num3 as a parameter, int num3 is equal to chi, num3 and use t for the y value, and you'll be able to create a 3D grid. This. So nested loop is pretty simple to use. It might be a bit hard to understand how it's being operated, but once you know it, it's pretty handy to use. And a lot of cases, in most of the cases, when you want to create a complex geometry, a complex operations, you are going to face this nested loop. Now let's end this by doing another exercise for this nested loop in order to see a bit practical usage, how this nested loop can be used. Okay, so I'm going to create another attribute triangle, and let's set it to detail as always, and then name this as exercise 4. Okay, and I'm going to create a helix as we did last time, but in this case I'm going to create a multiple number of helix rotated differently for each helix to create a multi-helix being placed in one positions. Okay, so I'm going to create two parameters, one for the number of points and one for the number of helix curves. Okay, and for the first parameter I want to set a bit bigger than 10 as a range, because that's going to be the number of points. And for the second parameter I'm going to keep it as in between 0 to 10, because that's going to be the number of curve that I want to create. Okay, now let's also have another angle ratio and height ratio as well, like we had before. Angle ratio, height ratio. Okay, promote this as a float value between 0 to 1. Right, now let's have a single loop first using num1. That's going to be the number of points. So let's create that point using this I value. I'm gonna start by creating x equal to cosine and float z equal to sine, and for the angles, which is going to be pi multiplied by ang ratio multiplied by I, and I am going to just copy this for the z value with the sine, and for the y value, which is the height direction, I'm going to multiply I multiplied by height ratio. Okay, and let's create the point to see if I get the single helix point arrays. So set x, y, and z like this. Oops. I need to say at point. Right, so now I have a single point array which I have been doing it. Now next thing I want to do is to use this num2 in order to create this same set in a different angle. Maybe I can divide 360 degrees with this num2 and rotate it by using the z-axis from the center. So if I have 3, then I can divide 360 by 3 and use 120 degrees to rotate this curve 3 times to have 3 helix curves, and then combine them together to have 3 lines as a result. Okay, so to do that I need a nested loop, and the position where I can do that could be somewhere around here to enclose this point creation code. So int n equal to 0, n is less than num2, n plus plus. Okay, so in order to use n, what I can do is to control, in order to use n to control the angle for the cosine and sine. So in that case, maybe I need to also have these values inside the second loop, like this. Okay, so first of all, as I said, let's try to divide the 360 degrees by the number 2 right here. And 360 degrees is actually, if you want to show it as a radians, can be set as, I'm gonna name it as ang multiplied by 2, pi multiplied by 2. Since pi is equal to 180 degrees, if you multiply by 2, you get 360 degrees. And then you want to divide it by a number 2, num2, which is going to be the total number of helix, which is this one. Okay, now maybe let's name this to step ang. And now you can use this to combine with the angle inside the cosine and sine in order to rotate the whole point curve by some constant value. To do that, you can just add some additional angle to each of the sine and cosine angle. Step ang, and you want to change the angle whenever you change the n value. So you want to multiply this by n. So first process for the n loop, which is this loop, you'll get the step angle to be 0. On the second process, you get this as 120 degrees if the num2 is equal to 3. And then for the third loop, you get 240 degrees, and you will end the process. You will end the loop because you have just run 3 times. And as a result, you'll be able to get things like this: 3 helix point curve being placed in 1 positions. And you can control the number of helix by changing the number 2. You can also change the number of points. This, right? So this is one of the practical way to use a nested loop in order to create a helix and multiple helix created by a VEX. Now, if you want to use add node to create a polyline for each helix, you also need to specify some attribute for each point, because as a default, what you get using a add node with the polygon with the by group option is just to connect all the points with one single polyline. To separate those polylines by each helix, you need to specify an attribute for each helix. And in this case, the n will be the identifier for each helix. So maybe the first helix will have a n equal to 0, a second helix will have an n equal to 1, and the last one will be n equal to 2. So you can add these n value as an attribute to each point to identify that each point is stored as a different group and stored in a different group. So let's use set point attrib 0, and let's name this, any name is fine for this one. Let's just call it ID, and the PT is the one that I have just created as a point, and n is the actual value that I want to store as an attribute to the newly created point. Now as a result, you'll be able to create a point which has an additional attribute called ID, and you have in between 2, 1 or 0. And you can actually use this attribute to separate the polyline going back to the add node. If you click the by group tab and go to a by attribute for the add options and set the name for the attribute, in this case ID, then you can separate the helix as identified by a value n, and as a result you'll be able to create 3 separated helix curve like this. And by changing the value num2, you can control the number of helix like this, and so on. So it's a bit of a practical way to use nested loop, one of the example which might show the possibility of nested loop, what you can do with it. So this is it for the loop, the basic of loops. So I hope you get a glimpse of idea how loop works, how you can use loop inside of VEX. And the next topic that I want to talk about in next video is conditions. I'm going to show you what condition is, how you can use condition together with the VEX with some simple exercises as well. Okay, so that's it for today. Thank you for watching, and please consider subscribing if you're interested, if you want to follow more, and would like to see you next time as well. Thank you and goodbye.